is parent functions and the transformations that happen to them. So first of all, let's take a look at what each of the parent functions are. Right? A parent function is just the simplest form of a function. So what we have are linear, which you can see our function is just going to go kind of diagonal through. You have quadratic, which is our classic parabola look. We have absolute value, the v. Cubic functions, which is that kind of S-curve look to it. And rational functions, which we will see as this kind of cool looking look to it. We're going to be focusing more on the center than anything else for that function. Okay, so when we see any of these things happening to x, right, if we have just plain old x, or if we have something squaring it, or maybe giving it to the third power, or we could actually go even further with these. Okay, there's more functions as well, but we're going to focus on just these few for right now. Okay, we want to know what will happen to that function if we start doing things to it. So let's take a look. Okay, we can have multiple types of functions, right? As you can see, we could have our cubics or our quadratics or linears, depending on what power we have here. Okay, or we could have, for example, our absolute value functions that we could be working with. Okay, what really matters is what's happening to it on the outside. Right, out here we have what would be either our plus or minus sign. If we have a negative sign, then all of these original functions are going to end up flipping upside down. Then we have the multiplier. If we have a multiplier that's larger than 1, we would end up having what would look like a taller function. That is, all of our values are growing at a faster rate. If it's a number that's less than 1, like a fraction, 1/2, 1/3, our function would appear wider because our function is actually growing at a slower rate. Then we have what we're either adding or subtracting inside of the function itself. Here it's a little bit tricky because we want to be moving opposite the sign of what we're adding or subtracting. Remember, we're moving left and right here. So if we had negative, we would want to move towards the right, which is positive. If we were adding a value, we'd want to move towards the left, which is the negatives. Okay, so we want to be moving opposite the sign. Then you have what we're adding or subtracting outside the function, which would move us either up or down, but we're going to follow the sign. So if we're adding 1, we would move up 1 unit. If we were subtracting, we'd move down. Okay, so let's take a look at what a function would move to, where it would move to. Okay, we have this example where we have -3 as a multiplier on the outside. Remember how we said the negative is going to make the function flip upside down, and the 3 is going to make it taller or grow at a faster rate. Okay, real quick, right? We're working with a quadratic, so it's going to be a parabola. So what we're picturing here is our usual U shape is going to be upside down, so it's going to flip like a frowny face, and it's going to be a much taller, so it's going to go really fast down. Then we have the -5. That's going to move the function to the right. Remember, we're moving opposite sign. And outside, we have +8, which moves the function up 8 units. Okay, well that's all great, but we want to see an example on actual coordinate plane. Okay, real quick before we do that though, let's take a few seconds to point out some general parabola patterns, which we'd call critical points. Okay, so for a parabola, we're focusing mostly on the vertex. Okay, from the vertex, if we were to take number 1 and plug it into a unit squared, right, a function squared rather, plug 1 in, we get 1 out. So we notice that we're going up 1 and over 1. If we plug in 2, we get 4 out. We're going up 3 and over 1. So the pattern that we're looking for a general parabola going to be up 1 over 1, up 3 over 1. And because parabolas are symmetric on both sides, we're going to notice that's going to go up 1 over 1 on the opposite side and 3 over 1 on both sides. Okay, so that's the general pattern that we're going to follow. Up 1 over 1, up 3 over 1. Okay, that would be a total distance of 4, which is what we're looking for. Okay, so those are 5 critical points. So when we graph a parabola, which we can see in the next problem we're going to have, we want to put our vertex first, and then we want to repeat this general pattern. Now, why is that pattern important? Because if we have a multiplier and we're moving at or getting taller at a faster rate, depending on what we're multiplying, that distance is going to either double or triple or be whatever the multiplier happens to be. Okay, so we have to have an idea of what that general shape will look like. So now we can tackle one of the problems. Okay, so we know we're working with a parabola, as we mentioned, right? We have a quadratic. We have no multipliers, and it's positive. So we're not going to flip upside down. We're just going to be the same U shape, and it's not going to get any taller or any faster. It's going to follow the up 1 over 1, up 3 over 1 pattern. However, we are moving it opposite of -3. So we want to move it +3. That's our left-right direction. And then we're going to move it down 2 because of this negative. So our general shape is going to remain the same as a parabola. So we're moving the vertex +3 and then -2. That's where the vertex lives. From there we can plot the 5 or the other 4 critical points. All right, we're going to go up 1 over 1, then up 3 over 1, and back to the vertex, up 1 over 1, up 3 over 1, and then we can plot the rest just real quick. Okay, that is the solution for that particular graph. Next example, we see an absolute value function. And we see the negative sign on the outside. So that means that instead of it being a V shape, we're going to be going upside down, kind of like an A. However, we have no multiplier. So the pattern for a parabola, which is just straight through the diagonals, we're going to just continue that, but in the other direction. We see +5. Positive means we want to go left towards the negatives because we go opposite the sign. However, we're going to move that V up 4. So 1, 2, 3, 4, 5, and up 4. 1, 2, 3, 4. That's the very tip of my function, and because normally it would be a V going up this way, we want it to go the opposite direction. So I'm going to move it down that way. And there you have your absolute value function. So why don't you try this problem on your own? Oops, a little bit too high up there. Okay, try this one on your own and see how you do with it. You can pause this video and resume and check your work. Alright, let's see how you did on this problem. This time I threw a multiplier at you. So let's see if you were able to make the function taller like you are supposed to. So we're going to deal with that actually at the end. Let's figure out where our vertex falls first. We have +4, which means that we want to go -4, so left 4. And then we have -6, which we follow the sign here, so down 6. So from the origin, we want -4 and then down 6. 2, 3, 4, 5, 6, right here. Okay. It's still positive, so it's going to be a U shape because it's a parabola. But instead of us going up 1 over 1, we want this to be growing twice as fast, taller. So it's going to go up 2 over 1. And then from here, we usually went up 3, but again, we're getting twice as tall. So we want to go not 3, but 6. 1, 2, 3, 4, 5, 6, and then over 1. And if we just repeat that on the other side, I'm going to go up and over, and then we'll plot the rest of the function just by drawing it in. Oops, I missed a little bit. That's okay. So that's what we want our function to look like for that particular problem. Hopefully you didn't have your points too far down because of this multiplier. You want them to be stretched up taller. Let's see a couple more examples. This one's an absolute value function. So remember, we're going to be making a V shape with this one. See what you come up with. Pause the video, check it out in a few seconds, and see how you did. Alright, so there's no multiplier in front of this one. There's no negative sign, so we're not flipping. So it's going to be the regular V shape. But that negative 8 inside the function tells us to go positive 8. And then we have a plus 2, which tells us to follow the sign and go up 2. That's where the center or the vertex, whatever you want to call it, of this function is going to fall. Okay, so let's see, we want to go positive 8 and then up 2. So here's where the vertex falls. And the rest of the function is going to look just the same as usual. We're not growing at any faster rate, so we're going to go through all of these corners this way and through all these corners this way. And that's that transformation for that absolute value function. Okay, if you have any questions, just leave them in the comments or let me know in class. I'd be glad to answer them anytime.